Okay, so today we've got a really quick power of 2 problem. I felt like it was relevant to address, even though I would say it's one of those criminally overused problems in mathematics. Although it does have an interesting variation on it, it's ultimately not too much to tackle. Okay, so we're all familiar with this basically meme of the year appearing in math problems. Most of these seem to involve something canceling so that you get a calculable number. Unfortunately, in this one, we don't quite get that, as it's just a bunch of numbers added, no real cancellations going on. Though it is important to note that while there is a more efficient way to tackle this problem, I originally solved it by doing it this way. Just seeing a bunch of negatives going all the way up to negative 2016, which isn't that efficient, but just goes to show that there always is more than one way to do a problem in math, and that you should really never think that you can't do something. Okay, so for this one, there is something that you'll just have to accept for now, which is S of n is equal to a sub 1 times 1 minus r sub, or r to the n, over 1 minus r. Okay, so this is the formula for a geometric mean, and in a later episode, probably either next one or episode 9 or so, something around there, somewhere in between there, we'll talk about this and another interesting fact that we'll discuss later in the episode is like a derivation for this formula, and another interesting tidbit that I'll talk about here at the end. So yeah, anyway, obviously this is a power of 2 episode, so um, we're going to use the powers of 2. You'll notice that this is a geometric series where a sub 1 is equal to 1 and r is equal to negative 2. Okay, so we simply plug this into the formula. Oopsie daisy. Simply plug this into the formula. And we're left with this. Okay, the last real challenge of the problem, as I say, is a rather quick one, is this, what do we put it to? It's easily something to get tripped up on. Many people would just simply hunk in the 2018 here and get the answer wrong. But it is, in fact, as this starts as 2 to the 0, it's also any given term in the sequence for powers of 2 would then be this. And then to get that 2018 exponent, we need 2009 for n. So just a quick thing, just don't get tripped up on those little things. It's quite easy. I do it all the time, but certainly something to look out for. Sorry. It's negative. Okay. I would love to verify that that is in fact an integer, but there's no real good way to do this. It is an integer, which is the interesting tidbit that I just said I would talk about. That all numbers in the form 2 to the n plus 1 are in fact equal to 0, or congruent to 0 in mod 3, which is a fancy way of saying they are divisible by 3. Okay, so that's something we'll talk about later, but now to just round off this problem, it's negative 2 raised to an odd exponent, which means that there will be a negative left over for us to just round off the problem by saying that this is this integer. And unfortunately, as the number is quite large, there's no real good way to simplify it. I spent a good 20 minutes trying to, but alas, it only just runs into a bunch of other random anyway. So, thank you for watching. See you guys tomorrow.